Great stuff.
I guess that's a cool.
He's good?
Sure.
I thought about doing flexible.
Right, so guys, just thought I'd go through a few things. We've got some news, and I've got a project that I've just been working on. It's really simple, but it covers a few things which you sort of want to learn about when you're starting out with MicroPython, so I thought it'd be worthwhile just having a quick look at how it does things. Anyway, straight into it. News. First thing was that Guido van Rossum, who's the benevolent dictator for life for Python, is no longer the benevolent dictator for life, per se. He's stepped down from his BDFL duties. So this doesn't affect MicroPython per se, but it was big news in the Python community. Why did it happen? Look, he's not a young guy anymore. He's been doing this for nearly 30 years, and he's done an amazing job by all accounts. But the last PEP, the PEP process is how Python goes through upgrades, so it's a way for the community to discuss how they improve the language. And the last one was particularly hard on him, I think. It was not a very popular decision. It was sort of 50-50 as to whether the change would go in, and we'll cover quickly what it was about. And he just got to the point where I think he's just a bit burnt out, and he was looking at retirement from the language in a few years, and I think it got a little bit nasty, I think, in the forums, and he was sort of a bit sick of pushing his opinion through. So unfortunately, Guido stepped down. He's still really involved in MicroPython, but he doesn't want to be sort of that point where he has to make the decisions on his own anymore. So that was interesting news. CircuitPython 3 got released. Now, CircuitPython, for those that don't know, is a fork of MicroPython by Adafruit. And so that's supported on all the Adafruit hardware that runs MicroPython. Version 3 is a major milestone for them. The main thing is the SAMD51 chip, which is a Cortex M4, is supported on it. They've also got preliminary support for the NRF52 range, which adds Bluetooth. So they've got a number of boards that have come out that will support CircuitPython 3, and all of their older stuff that supported the older 2.x now supports 3.x as well. So it's good stuff from the Adafruit guys. They're absolutely running with this stuff. So they've got like a Discourse server where you can... Discourse, is that name? Discord, thank you. Where you can log in and throw your 2 cents in, and it's really well managed, and it's really active. It's like 600, 800 messages a day. Like it just... It's nice to hear what else.
Is CircuitPython open source as well?
It's open source as well. Yep,
So
same license as MicroPython. There's good collaboration between the two projects. CircuitPython's got a slightly different focus. It's more aimed at beginners, per se. I guess that's where their focus is. And so they had, I guess, a few things they wanted to do differently to MicroPython. So they forked the language to go their own path, but there's still a lot of collaboration. Still stuff coming back upstream, for example. Got here MPUG. So MPUG's the bit of Python news this month. MPUG's the Melbourne Python users group, and so Damien, Nick, and myself are going to present their a taste of MicroPython is I think what Damien wanted to call it, which seems a bit weird to me, but sure, it'll be good. So they've got a group. They usually have like 50 or 60 people. Python's very popular here in Melbourne. So we'll give them an introduction to MicroPython. We'll try and cram that into about a half an hour. So if you guys want to come along, I think it's on the 6th of August. It's a Monday night from memory. It'll probably be, you guys probably know more than the average Python user would know, so it might not be that interesting to you, but I went along to one of their meetings and they were really excited about hearing something different that Python can do, so that's interesting. And then we've got PyCon coming up. That's at the end of August, and so Damien and I are both presenting there. I'm talking about asyncio. Damien's talking about how to make MicroPython really fast and really efficient. And just recently they've announced a couple of their keynotes or their invited speakers. So that's kind of cool. And we now have a blog. So last month I put together a quick blog which just captures all the slides that we do and any notes that we have, so you can go back and refer to them. Damien's been really active with the newsletters now, so he's trying to get that out every week or two. So you can go register for MicroPython newsletters, or you can go look on the MicroPython forum, and I'll let you Google all these, they're easy to find, and I've got links in the slides which will be on the blog. But yeah, Damien tries to cover a topic or two at each of those newsletters to share around some of that MicroPython news. And just finally, I wanted to talk about the Bluetooth API. So Bluetooth's not yet supported on MicroPython. There's been a couple of people who've had a hack at making an API to run on MicroPython. but there's a small team now of a couple of those guys who've had attempts at it that are coming together again. They've forked the MicroPython repo, and they've got this little snippet. Doesn't look like much, but that's running on 2 different ports, 2 different blobs of hardware, and that's the start of what they've done. They've also put together a document which outlines what they intend to do, and they're looking for people to comment on it. So if you've got an interest in Bluetooth, get in touch with me and I'll put you in touch with them. So that was that. Right. Just quickly look at PEP 572. This is the one that was the end of Guido, which is a horrible way to say because he's still doing things. If you want to go listen to a podcast, Python Bytes and Talk Python, I mean, they're both Python podcasts that cover this topic pretty well. Michael Kennedy's a really good podcast host. But from Guido's transfer power email, I don't ever want to have to fight so hard for a PEP that was so highly despised, was basically the summary there, and so that was what tipped me over the edge. Generally, the I guess the reception of this was just one of gratitude, because he's done an amazing job for, it's 28 years I think Python's been around for, and I think it's not just the fact that he's stewarded the language so well, he's also done it with a lot of respect in class. He's widely regarded as someone who's been really good to work with, so I just want to say thanks to Guido. And just the point here, please be nice out there, because even someone like Guido who's got pretty thick skin after 28 years really felt it after this. So, the other thing, the actual PEP, what did it cover? Basically assignment expressions. So in Python with it's targeted for 3.8, you'll be able to assign something and then compare to it. And previously that's 2 operations. So they've introduced this : equals syntax. So you assign to something and you can test the result of that. And the nice thing is that is captured, so in that block you can still use that. Previously you would probably have done the pattern match outside of the if statement and then done the test. This sort of streamlines that. So I guess why people were up in arms about this, I guess it's sort of seen as the start of what was seen to have happened in Java and C#, where the language kind of got bigger and bigger and heavier over time, and people felt that this wasn't really giving enough value for the streamlined syntax. But as I said, there was camps in both, pros and cons. Okay, I thought I'd have a quick look at gaming devices, because I've got a couple here and I want to show them off. So the first one is the Odroid Go. The reason I'm showing these is because this is effectively like running a little game emulator. So this is Tetris running on a Game Boy, but it's running on the ESP32, which we all use pretty heavily for MicroPython. These actually get killed in Australia. It's $77, but they sell them online for about $35 American or something. We get reamed for shipping and stuff. But it's got a whole bunch of stuff. Sound. You need that. It's good that it can be muted as well. Frustratingly, it doesn't have a headphone jack. But it supports Nintendo Entertainment System, Game Boy Color, a few other bits and pieces out of the box. So that's what you get out of the box. It's got micro SD cards so you can store your ROMs. It's got a battery, speaker, it's got a whole bunch of stuff. It's also got a header at the top here, so it's got some GPIO broken out. And they actually have examples on how to connect a second LCD display to it, and humidity sensor and stuff like that. So you can get the weather. You can have it set up as a weather system. But the thing I like is you can run MicroPython on that as well. So that's kind of neat. And then you go from the sublime to the ridiculous, and we've got the Pocket Sprite, which is another one of these gaming emulators, and it really does actually work. It's got a tiny little OLED, which is about a quarter of the size of the original Game Boy display, but it emulates all the same sorts of things that the bigger brother there does. They're not related at all, but this thing, it's not actually, it's a real thing. It's pretty crazy. And so the guy who built this, it took him about a year and a half, and he was inspired from years ago because he saw someone had made a little model Game Boy, and it was just a clock. It just had the time on. He's like, I need to make one that actually works. And so that's what he did. I haven't done it yet, but this should run MicroPython just straight up. It's a straight up ESP32.
Comes with sound as well?
It does. Yeah, it's hard to see, but there's a little speaker with some little cutouts here. It's a beautifully made little thing. Let's see if I can get sound coming out of this easily. Is it playing?
I'm looking for a solution for sort of like diagnostics for a vehicle for people I work for, and I'm just thinking it'd be really funny if I could just give them a Game Boy.
Yeah.
Plug this in.
That's
And you can make the noises and everything.
Let's see if I can just reconnect it. Huddle around the screen a little bit, please. Pocket Sprite, yeah, tiny. By the way, the Odroid Go, the bigger one, has the Rover, which is the big daddy of the ESP32. So it's got 4 meg of flash and 16 meg of flash, 4 meg of RAM, which is quite neat. And finally, I just wanted to mention that Adafruit also announced that they're going to be doing one as well. So similar sort of style to the Odroid, maybe a fraction smaller, but they're actually going to do it as a feather wing. So they have a range of processors that you can buy that are in this feather sort of scale. I've got one here. So they've got a whole bunch of processors that share that same layout, and so the idea is that they would bolt on an LCD with sound and whatever else, so you can plug into that. They look like they're targeting the new Cortex M4 for that, so stay tuned. I'll let you know if and when there is something. Yeah, and that is it for news.
Did you assemble the Odroid Go?
Yeah, so the Odroid Go comes in a whole bunch of bits, like the two halves. It even has like press out, like these plastic bits come in like a frame. You've probably got a photo there. Yeah, it's pretty cool. And of course I didn't follow any instructions, and naturally I've missed 3 screws inside it. But yeah, it's pretty cute. So yeah, I might get MicroPython running on that tonight. It should be just a straightforward dump on it. I also got one of the Fires. So we talked about this last month, I think, maybe. So M5 are a company, Chinese company, who make this little housing, which they come in a few different configurations. So this was their original M5 stack. Beautiful little development kit for ESP32, MicroPython in particular, because they break out all the female pins on the sides. It's really well packaged. It's 320 by 240 LCD, a couple of buttons. It's got everything you sort of need to play with to get started. I guess the Fire is, well, it's bigger, but it's got some neat little features. For starters, it's the Big Daddy. It's got 16 meg of flash and 16 meg of RAM, which for a microcontroller is a bit obscene. It's also got this magnetic plate, so you can leave your USB plugged into that and just drop this on. It's cute. I'm trying to demonstrate. They've got a couple of panels on the side which have got the NeoPixels. They've also got like accelerometer and other stuff. It's got all sorts of things just tossed into there. And it also comes with Lego, which I feel is important. So you can plug Lego in and you can use it as a control for, or a replacement for like the Mindstorms sort of stuff. It has sound as well. So,
Sorry, who makes that?
M5 Stack is the name of the group. They sell it through, they've got a shop on AliExpress. Also, what else have I bought in terms of hardware news? I bought a few WeMOS boards as well. So WeMOS also make a bunch of ESP8266 and ESP32s. So I've got one right here somewhere. So they got the new design for the ESP32, which is their branding is the Lowland D32, which is the standard ESP32, but they also sell it as the Lowland Pro as well, with the Rover on it, with the 4 meg of RAM. This one's got the 520k RAM, and a bunch of ESP8266s as well. So if you want to play, just come let me know and grab one. That's about all I've got for you in hardware news. That's about it. Any questions about any of that?
No.
I'm speaking quickly because I was trying to get through. I need to talk about it.
I would be interested in the Bluetooth stuff. We'll be doing that
Yeah.
with a little light thing at some point.
Yeah, so there's a couple of things that are interesting there because 3 of the guys who've been involved have already had a crack at this before, and so you can go into the MicroPython GitHub and go look at the history. There's quite a lot. And the good thing is that although it never eventuated into going into language for various reasons, mostly it's difficult to define it such that it works well across the various ports.
Yeah.
That's where they were sort of stumbling. There's a couple of things that are coming together, mostly A, experience, and B, Damien's coming along with his board, the PyD, what do they call it, the PyDB? Yeah. Anyway, the new Pi board is soon to be released. That has Bluetooth on it, so Damien's certainly motivated to get Bluetooth in there. So, yeah, and these guys seem pretty organised. The document's quite a few pages long now, and it just talks about what they think they need and what they think it should do. And they're talking about having like a high-level API so you can do beacons really easily, as well as like a low-level API to do whatever you need at the gap level. So,
yeah, great.
it's pretty cool. Pretty cool effort.
Yeah, I'm certainly going to have to look into that.
Yeah. All right. Let's see if we can get this running again, because it'll be useful to show off my new project. It's just not working. All right, we'll have to do it in here. A moment. We can edit this out, right? Make it look professional.
This is live streaming.
Okay, fantastic. Right. So, this little thing here is just a standard ESP32. Hopefully it restarts. Okay. So I'm calling it MicroPTV. I need to call it something for you guys. And the whole point was to display the... This is something I've wanted for myself. So I want to display the next 2 trains that are coming at my train station near home. Right? I need to know how many minutes they are, because once it gets down to 6 minutes, I have to run out of the house to catch it. And same with the tram as well at work. Although we're just outside of the tram stop, you've got to cross a road, so you need to allow 5 minutes, right, like, to get to there. So this is... That's unusual. This is displaying the next 2 trains to Eaglemont Station, where I live. Next one's in 12 minutes, and the one after that's in 35 minutes. So I've got time, I don't need to run right now, which is good. The reason I thought it was worthwhile showing off this at the moment, it's a bit rough and ready, but it covers a few things that you'll often want to use, like connecting an SPI device. So this little display is an SPI controlled LED matrix. We can talk about what SPI means. If you're not sure, come grab me, we'll talk about it later. It's just a way of communicating with devices from a microcontroller. It uses a network query, so you're making an HTTP call over the network. And it's also using async code, so it's using concurrency there, and it helps pull all these bits together. And I think it's a really strong case of why MicroPython's a really good language for this. It makes it really easy. So, if you think about what this thing has to do, it synchronizes to the system time, so it uses NTP to synchronize that time. It does that I think I've got it set for 10 minutes at the moment, right? So just make sure that the clock on the ESP32 is correctly set. It queries the PTV API, which they've thankfully got a nice RESTful API which you can access. And then it compares those times and updates the display if it needs to, so all that's pretty straightforward. I've got 10 minutes. That's good. Right, so the first thing is urequests. So if you've used Python much, there's a very popular requests library, which is designed to get HTTP requests very easily. You might not be able to see very easily, but this syntax follows almost the same. It's not as full-featured as requests. We're still building up support in the library to do things like follow redirections to the nth degree, and there's a few things missing, but in general, like to do a get, it's literally a one-liner, right? Response, get, URL. Right? When you get that response, you can then query it. There's a built-in JSON command, so in this case, that's what I'm using. The data comes back in JSON form. Again, if you don't know what JSON is, come talk to me. There's no dumb questions. So in this example here, there's a website you can go to which returns your IP address in JSON form, right? So they get the IP address and display it in JSON. That's 2 lines. It's beautiful. And so if you're an embedded developer that's done C before, you'll probably appreciate that this is vastly different, right? Like, you can do this interactively, and you can do it like in a couple of lines of code. It's fantastic. The PTV API is actually a really well-defined API. You can get the stops for all the routes. In Melbourne, you can get things like disruptions in which you're active. You can get how many minutes out to the next train, tram, and bus. Yeah, it's really good. And it's been defined with a Swagger UI. So if you've done web development, you might be familiar with Swagger. It's a way to define APIs so people can interact with them very easily. So we can have a look at that in more detail later. NTP it's quite primitive in MicroPython. You've got just the basics, and it only works on the ESP8266 and the ESP32 port at the moment. But it works. The main reason it's primitive is because there's no time zone support in MicroPython yet. So right now the system can be synchronized to UTC, but that's all you've got. The good thing is that it's a one-liner, right? NTP time dot set time, and now your system's synchronized. Technically, it's actually SNTP, which is simple NTP, but still, it's exactly what I needed for my project. So that's helpful. There's also a bunch of time functions, and they also mirror the Python syntax as well. So, in particular, you deal with a tuple for time. So it breaks it down by year, month, day, hours, minutes, seconds. So you have a tuple, and you can then from that tuple go back and forth between retrieving the number of seconds since the epoch. Right? So MicroPython gives you those same sort of commands. There's some differences. The main one is no time zone support. So regular Python adds that to that tuple. So you've got a couple less fields in MicroPython. The other one is that the epoch differs. And I was going to ask Damien tonight why it differs. I think it's because MicroPython's synchronized to the year 2000, first day of year 2000. Regular Python synchronizes to 1970, the original Unix epoch. I think the difference there is just the one of size. Some of the microcontrollers are pretty low in size of integers that they can handle. So when you're talking about seconds from the epoch, I think you're pushing it from 1970. But I don't know, that's just a guess. So in any case, there is that slight difference. The lead matrix control, so these things here, they're actually pretty amazing because you can buy these on AliExpress for less than $5, and there's a chip behind each one of these. If we pull one of these guys off, this is a chip for each one of the displays. You can see it there. And so you throw SPI data, which is just a way of sharing data from microcontroller to devices, and you can daisy chain these things along, so you can actually connect these up for as long as you want to go. And the way it works is as you send packets, until you terminate the packet, the micro will actually just keep passing them on. Right? So these, sorry, not the micro, the chip here, will just keep passing them on. And so eventually all of them will get some data, and then it'll be terminated, and then they'll get displayed. But the chip takes care of doing brightness and control, so you just give it some binary data and it displays it on the matrix, which is quite neat. Thankfully, we've got an Aussie guy, Sydney guy, Mike Kauser, who has put together a MicroPython driver. It's about a page of code. It's really not much to it. It's built on the FrameBuff library, which is in MicroPython, which just gives you a general way to do a canvas drawing. So he uses that and then sends it via SPI to the device. Very simple, very nice. So you can possibly see it here, I'm not sure. To create one of these, we just need to create an instance. Is that pizza? What time is it?
8:05.
Ooh, probably is pizza. So yeah, SPI already comes in MicroPython, so we just need to create an instance of that device, and then we pass that to the max. So these chips are called Max 7219, really common, and that's what the library deals with. Really easy to create an instance of those and then just drop text onto them. It's and then mine. Right, so asyncio is a bit harder to get your head around. This is the built-in, it's standard in Python, but MicroPython gained it a couple of releases ago. It's where you can do concurrent things. Now, it's not multi-threaded. It allows you to create tasks and then have them interact with each other by relinquishing control. So it's cooperative multitasking. It all sounds difficult, but it's actually a really easy way to do things. You see here, you get an event loop, is what they call it in asyncio, and you create tasks. In this case, I'm creating 3. One to go get MTP, one to query the time from PTV, and the other one to check the time and see if the display needs updating. And then I just run them forever. That's all I do. And because each of those methods have been written such that they give up control when they're finished doing what they need to do, then the other methods can jump in and keep going. So NTP runs every 10 minutes or whatever it is. It's doing nothing most of that time. It just relinquishes control. Right, so code is going to be really hard to see.